Hey guys, welcome to another video where I'll be breaking down two of the shots I created from my latest Blender simulation video and show you exactly how I got these interesting molecular simulations in Blender using the molecular script and some shading tricks. Without further delay, let's dive in. So in order to have self-collision between particles, we need to install the molecular script for Blender. So we'll go to the GitHub page and search for Blender molecular script, and I'll just choose the Windows version and save the file. And we'll jump back to Blender, and if we go to preferences, add-ons, and just look for the zip file, we can activate the add-on. And now if we create a cube and go to the particle setting and add a new particle system to the cube, you can see we have the molecular script activated in our scene. So now next we'll add a cube to our scene, and I'll scale that down in z-axis, and I'll go into the edit mode and select the front face and do an inset operation on it and just create a face like that, and also extrude it down a little bit. This will be our container, so rename that as container. Next I will select the container and go into our physics properties and set this as a collision object so that our particles interact with it, and set the friction to 0.8 and the damping as well to 0.8. Next I will create a new cube which will serve as our emitter, so I'll select that and just put it right above our container and scale that down a little bit so that it's inside the boundaries of our container. So I'll select the emitter and I'll create a new material, and I'll replace the principal BSDF with a principal volume with 0 density, so that our cube is actually not visible in the render but the particles are. And I'll also create a UV sphere which would serve as our particle object. Alright, so I'll select the cube and I'll rename that to emitter, and also I'll go into the particle settings and assign a new particle system to the cube, and actually change the end to 1 so that our particles stay at 1 frame and don't emit throughout the range. The other thing I'll change is the lifetime to 500 so we don't have any dying particles, and also change the emit from faces to volume, and I want them to emit in a more grid fashion. I'll also change the resolution to 30, and then going down I'll turn on rotation and also give a bit randomized rotation to the particles, and change the render as an object and choose our sphere as our instance object. And now they are all intersecting with each other, so I'll change the scale to 0.02 so they are a little bit apart. Perfect. Now we can go ahead and turn on molecular. So our simulation range is from 1 to 250. Another thing I need to turn on is actually activate self collision, so the particles are interacting with each other and bouncing off. And we also need to change the damping and friction values, so I'll change the friction to 0.3 and the damping to 0.6. And I think we're good to go, so I can start the simulation by hitting this start molecular simulation button, and I will start the simulation, and I'll be back when the simulation is done, when we have something. So we are back and our simulation is done and all baked, and if I press play, you can see all the particles are dropping in this container. And because we have less friction value in our active collision properties, active self collision properties, it gives us this sort of nice constant wiggle in our particles so that they don't look static at any point in the shot. So the very first shot I'll try to recreate from the video is this little guy over here. So if I were to just explain to you what's going on in the shot and how the force fields are interacting with the particle system. So there are two fields in the shot, one in the foreground and one in the background. The background one moves across our scene, causing this moving heap of particles, and the foreground one just stays at one place but causes some turbulence in the particles. This way we get some depth in the shot. So let's go ahead and create these force fields. So we'll select our emitter and go to add, and we'll add a force field called force, and I'll move it somewhere on this side. This is going to be our starting position of the force field. And if you go to the force field settings, the very first thing I'll change is I'll put this to -15, because by default it will be pushing the particle downwards. So we actually want the particle to be pushed upwards towards the center of the force field. And the next thing we'll change is we'll have a little bit of noise in the force field. And also I'll use the maximum and minimum to give a little bit of a fall off. So the maximum distance where I want the force field to affect the particles should be around 0.5, and the minimum should be 0.2. See, all the particles within this range would be definitely affected, with a bit of a fall off after this region. So if you go to our very first frame and play the simulation, we can see that the particles settle somewhere around frame 30. So that should be our starting frame. So I'll select the force field and then set a keyframe, Shift S, and set a keyframe on location, and I'll just drag and then go to frame somewhere around 130 and move the force field in the x-axis like that, and set another key at the location. And so now we have our force field animated going across our particle system. So I'll go back to the, actually I'll first rename this to field 01, and I'll go to the emitter particle system and then press free all bakes button. That will kill all the cache currently in the memory, and I'll start the simulation again. So we are done with the simulation, and as you can see, as the force field is moving across our particle system, it is displacing those particles. Some of the particles are falling off the container, but that's okay because we are not going to render that far. So the next thing I'll do is split the interface into two and create a camera. Add camera and go into the camera view and make sure we are looking through the camera and the view is locked. And I'll just try to frame all the particles and also try to have some foreground particles for some depth in our scene, something like that. And the other thing I don't like is this passport out thing, so I'll just go into the camera settings to viewport settings, viewport display, and then go into passport out and just turn up the opacity so that I have black around the frame and I'm just focusing on the frame. So now I'll go ahead and create our second foreground force field. So let's go into add, make sure the emitter is selected, go into add and force field force, and I'll position it somewhere near the camera, and I'll go into the force field settings, and for this one I'm just going to choose -15. We don't want it to be that strong, it just have to be a subtle movement, and the noise amount to 10. I'll check minimum and maximum. The minimum could be 0.1, sorry, 0.1, and the maximum to 0.17. So it's just going to be a small range of particles. And then we'll go back to the emitter and resim. First we'll kill all the cache in the memory and start the simulation once again, and let's see what we get. Alright, we are done with the sim, and this is what we have. I think it turned out pretty okay. We have our foreground particles and also the background one just sweeping by, so that's all good. One more thing I'll do is actually select the camera and just rotate it a little bit like that to create a little bit more of a dynamic shot. And another thing I like to do is go into the emitter settings and increase the subset to 6, which will give us a little bit more accurate simulation. Alright, so let's start shading the particles. So the very first thing I'll do is actually populate the world with an HDR. So if you go to the world settings, I'll turn on my HDR gaffer tool, which allows me to cycle through various HDR collection I have. So I'll go to the browser and I'll switch to the one I used in my video, which was Artist Workshop 1K HDR. I switched to cycles. This is what we have. The other thing I'll do is reduce the brightness on the HDR. That's looking good. I don't want this container to be visible over here, so I'll just select the container, go into the object properties and turn off the ray visibility for camera. And the other thing I'll do is select the camera and turn on our depth of field, so you're getting this nice shallow depth of field. Alright, so next we'll start shading the particles itself. So I'll select the sphere and create a new material. I'll get the base color down to something like gray, and also reduce the roughness to 0.2 so that they look a little bit shiny. Now in order to create this random emissive particles, it's actually quite simple. So we're going to use particle info node and also get a mapping node. And if you connect the random output of particle info node to the mapping node, and if you have node wrangler enabled, you can press Ctrl Shift left click to view that particular node. So as you can see, I'm getting these varied levels in my particles, but I don't want that. I want them to be just isolated to some particles. So for that, let's just create a color ramp and we'll just pop that in like that, and I'll bring the black level close to the white. And as I do that, you can see I'm shrinking down the region. Now to have the emission shader on these particular particles, what I'm going to do is I'll create an emission shader and then choose our desired color, that too, and also create a mix shader. So I need to mix between the principal BSDF shader and the emission shader using our newly created mask. So I'll connect the BSDF to the first input of the shader of the mix shader node, and the second one to the emissive shader, and then use the color output of the color ramp as a factor. And if you see that, we have successfully created the emission shader on just those particles using the particle info random output. So yeah, that's how you create the shaders for this particular shot. Moving on, I'll show you how I ended up creating this one over here, which requires a little bit different shading technique, and also there's a different way I am displacing the particles. Alright, so to create those nice waves in our particle system, what we need to do is actually use the ocean modifier on a plane, which would displace the whole system. So for that, let's create a plane roughly the same size as of our container. And I'll go into the edit mode and make sure the plane is subdivided enough so that our ocean modifier has enough to play with. That's good enough. So you select the plane and add an ocean modifier to it, and then scale it back again actually. So I'll tweak some of these settings over here, but before doing that, let's just animate the time. So I'll set that to 1 at 30 and go ahead and animate till 140. Set a key again, make that 4, something like that. So now it's animated. I'll also change the scale to 3 so that it's a little bit more choppy and we get enough effect on our particles. Alright, so let's go ahead and delete the fields we have from the previous shot and position our ocean just right beneath the particles. And I'll go into the physics setting of that ocean plane, and I'll set that as a collision geometry, and give it a damping of 0.8 and friction of 0.8 as well, so that the particles are not hitting and bouncing off too much. So let's go ahead and simulate this, and let's see what we get. Alright, so we're done with the simulation, and this is what we get. So we're getting this nice wavy animation throughout the particle system, and it's looking all well and good. So if you look at the shot from the video, I've placed the camera to the bottom and it's looking up, but our system is laying flat. So what we need to do is actually rotate the whole system vertically, so that I can place my camera. So to do that, what we have to do is actually make sure that our particles are falling. Right now they fall in the z direction. We need to make sure that they fall in the x direction on this side. So we'll go into the scene settings, and the gravitation is acting in the z direction. So if you make that 0 and just put minus 9.8 in x, so the particles will be falling this way now. And now we can just grab our geometries and the emitter and just rotate the whole system just like that, and actually just move it a little bit up the grid. So now when we do the simulation again, the particle will be falling this way. Next I'll go ahead and create our camera. So let's split the viewer into two, and we'll create a camera. And we'll also make sure that we remove the ocean modified plane from our render. So we'll select that, go into the object properties and turn off the ray visibility for the camera. Cool. So next we'll go ahead and start doing the shader setup for our particles. Alright, to get going with the wavy pattern going on for this shot on our particle system, I'll start with a particle info node again, and I'll also get a Musgrave texture which will serve as our wavy pattern over the system. And this time I'm going to start with the location output of the particle info node, which gives you the data regarding the particles current positions. So I'm going to take the output of that and then plug it into the vector input of the Musgrave texture, which will help us drive the Musgrave texture. And I'm going to tweak some settings over here. So if I view the Musgrave texture, this is what we have. So the scale is a little bit too small right now, so I'm just gonna reduce the scale value to have a little bit more wider coverage. So let's just reduce that to 0.5. So next I'm gonna grab a mapping node. So using the mapping node, we can actually move the Musgrave texture in our particle system to the right depth and scale. So I want to scale the Musgrave texture in X so that it goes to the right depth. So if you do that, so let's put 10 over here in X, and so right now you can see we have a very general gradation from white to black. So I want to break that up a little bit. So for that, let's just grab a color ramp node, and I'll also take the output from the random of the particle info node and put it in the factor of the color ramp. And if I just view that, I get my random texture. So I'm gonna take this and then multiply it with the Musgrave texture, so that I'm just getting the random texture in those Musgrave textures area, if that makes sense. Let's plug in a mix, no, not a mix shader actually. Oops, sorry. So let's plug in a mix RGB node, and the color one should be the random texture, and the other one should be the Musgrave texture. And then if you change the mode to multiply and turn that up, there you go. So now we have some breakage in our pattern. Alright, so we're done with our mask. Next I'll do the same thing I did in the previous shot. So I'll grab a mix shader and the emission shader, make it all desired color, and I'll mix between the BSDF and the emission using our newly created mask. And if you see that plugged into the surface, there you go. So now we have our baby musky texture in on our particle system, which evolves and moves as our particles move, So yeah, that's how I created the simulations for the video. I also used turbulence and vortex fields in other shots. So go ahead and mess around with the techniques I just showed and post it online, as I would love to see the results you guys get. Thanks for staying with me and watching the video. Let me know if you liked it in the comments below, and please consider subscribing to the channel. It's a huge motivation for me to keep pumping out more tutorials and videos. So yeah, thanks for watching, and I'll see you in the next one.